Hi, it's Pearson, the science teacher. If you have been having challenges understanding chemistry concepts, the possibilities you haven't paid attention to the periodic table. So let's learn the periodic table today in this lesson. So to begin with, a periodic table is basically just a table of elements, non-metals, and metals. Let's start with identifying groups of the periodic tables. So, as we can see, groups written group numbers are written in Roman numerals. So this is group 1, this is group 2, this is group 3, group 4, 5, 6, 7, and 0, which represents group 8 there. I don't know if you also find the position of hydrogen here fascinating. Look, hydrogen is positioned just alone here. In short, we can say hydrogen is positioned here deliberately between group 1 elements and group 7 elements because it behaves that way sometimes. Sometimes it behaves like group 1 elements, sometimes it behaves like group 7 elements, halogens. So in which way? We're saying hydrogen is able to lose an electron and become a positively charged ion, which is H+, and it's also able to gain an ion and become a hydride. So let me just show you these two ions on the blackboard. So we can have hydrogen with a plus. That's when hydrogen has lost an electron, and we can have hydrogen and a negative, which is hydride, and that means hydrogen has actually gained an electron. So this is why it's basically placed in between group 1 elements and group 7 elements. Now, before we go any further, I think let's take a look at the key of this periodic table of ours. May take the camera closer. So we can see that the number up of this element, any element particularly that we are going to pick, is called the relative atomic mass. That's the mass number of that element, and it has in it the protons and neutrons that are found in the nucleus of this element. So the number down here is the proton number, the number that represents electrons. So as we start giving examples, we're going to use this key. This X is simply the symbol, which can be TH for thorium, which can be Ce for cerium. So that's just a symbol. So mass number and atomic number, these are very important when you're looking at the periodic table of each element. So for instance, we can see that the mass number of hydrogen is actually 1. Also, the atomic number is 1. We can see that the mass number of lithium is 7 and the atomic number is 3. This means that it has 3 electrons altogether, and it has protons and neutrons that are going to give us a 7 when we add them. But we have to know that the number of protons in this 7 is equal to the number of electrons down here. Yes, so at this stage, I think just allow me to take you back to how to draw electronic structure of elements so that we can get a picture, because we're going to use that theory to prove a lot of concepts here. So in this example, I'm going to use the same lithium, and I'll use, let me just pick any non-metal. I'll also use nitrogen. But someone would ask to say, but how come I'm able to tell that nitrogen is a non-metal and lithium here is a metal? So there, just note that there is a zigzag line that you can draw here. There's a zigzag line that can guide you. Roughly, get your own periodic table and draw this just to help you. So all these that are here are non-metals, and all these on the other side here are metals. So basically the periodic table contains 80% of metals and 20% of non-metals. As we can see, the portion there is small. So allow me to use the blackboard from this stage. So we said lithium This is the symbol for lithium, and it has its mass number 7 and its atomic number 3. So if we had to draw the atomic structure of this lithium, we know that it's going to come out as follows. We're going to have, this can be the first shell, and we are going to have 2 electrons. Okay, we have 2 electrons from 3 electrons. How many electrons are remaining? Only 1 electron is remaining, and that is going to go in the second shell there. So basically the point is, the first shell can only have 2 electrons. Then the next shell can have electrons up to 8 or less, and even the other one, and another just up to 8. So this is lithium. Yeah, so using this electronic structure that we've drawn, we can tell that lithium is actually in group 1. How? Because it only has 1 electron in its outermost shell. So we are sure that it's in group 1. Nitrogen, this is the symbol, and it has the mass number of 14 as well as the atomic number of 7. So if we apply the same information that we had applied, we are going to say this is nitrogen. Sorry for the camera that is away. So this is nitrogen, and it has 2 electrons in the first shell. Then it's going to have 1, 2, 3, 4, 5. How many are they altogether? 1, 2, 3, 4, 5, 6, 7, which is this 7 here. So let's count the electrons that are in its outermost shell, just this shell. We are going to find that there are 1, 2, 3, 4, and 5, which means it's in group 5. So we can conclude that nitrogen is in group 5 because it has only 5 electrons in its outermost shell. The other thing we can talk about concerning the periodic table are the periods. So the periodic table has 7 periods. Now, which ones are periods? So the fact is, the rows are periods. These are all periods, and the columns are what? Are groups. So as we can see, this is group 1, group 2, group 3, group 4. But we have these elements here that don't happen to be in group 2 or group 3. These elements here are called transition metals. They are put here because their valences vary. They don't have a specific valence. They don't have a specific valence of 1 number. Like in the case of lithium, lithium's valence is just 1. But you might find that we have iron 3, we have copper watt. So these have a variety of valences. Yeah. So with periods, this is how periods are counted. The best is to count starting from helium. So 1, 2, 3, 4, 5, 6. They are actually 7. So the 7 that I'm counting here, as you can take a closer look here, where we have 57. After 57, we need to have 58, but 58 is found down here. So this whole row is supposed to actually be somewhere there. That's where that row is supposed to be. So you find that if you fix there, you're going to have just 7 periods, 8 groups of the periodic table. Now, what else should we know about periods? So the periods of the periodic table show us or tells us the number of electron shells that an element has. We can give the examples. We are going to pick 2 elements from different periods. Let's pick the same helium. Let's get neon, and let's get argon. Let's get to draw them. So let me show you the atomic numbers. So we're going to use this 18, this 10, and this 2. So let's go to the board. So if we take a look at helium, let's draw the electronic structure. It's going to have only 1 shell, and it's going to have these 2 electrons in this shell here. So this is helium. So How many shells does it have? It only has one shell. Let's go and prove. What is in which period do we find it? That's period 1. So period 1 shell. The second element that we are going to use is neon. I just write it down here. Neon. Neon has a mass number of 20 and has the atomic number of 10. So let's draw again. When we draw, we are going to have the first shell having how many? 2 electrons. Then we are going to have a second shell having the shells that are remaining, the number of electrons that are remaining. So 1, 2, 3, 4, 5, 6, 7, 8. 8 plus these 2 will give us 10 electrons, which 10 is 10 here. So how many shells does it have? Shell number 1, electron shell number 2. In what period of the periodic table do we find it? We find it in period D2. The last example, let's go to the last example. So our last example is argon. This argon has the mass number of 40 and the atomic number of 18. That's 18, I hope you can see. So if we had to draw the electronic structure, we are going to draw the first shell, and this first shell is going to have 2 electrons as usual. Okay, how many more remaining? Let's see. We're going to have 8 here. 8 plus our 2 will have 10. So 2, 4, 6, 8. Okay, so we have 10. Remember, our electrons are 18. So let's draw another shell. If we draw another shell, sorry, the board is slippery. So if we draw another shell, then we put how many? 8. And 2. So 8 plus 8, 16 plus 2, we have 18. This 18 here. How many electron shells do we have? We have 1 electron shell, 2 electron shell, and 3 electron shells. So 3 electron shells. In what group of the periodic table do we find argon? That is period 3. I don't know if I said in what group, that was a mistake. In what period of the periodic table? We find it in period D3. So this is true, that the period number shows us or tells us the number of electron shells each element would have, or a particular element would have. Let's proceed. By the way, did you know that the number of electrons in the outermost shell of an element determines its position on the periodic table? Let's observe. For instance, we have hydrogen. So if we have hydrogen, its mass number is 1 and its atomic number is 1, which means in its outermost shell it has only 1 electron. If we had to draw, we're just going to have 1 electron, and whether it's labeled or not labeled, we can still tell that's hydrogen because it has only 1 electron in its outermost shell. So what we are saying is this would be true if we had to get helium, which happens to be the second electron, helium, which has the mass of 4 and the atomic number of 2. If we had to draw it, of course we know that it will be just 2. And if you go on the periodic table, it's a second, element. Yeah. So for lithium, lithium has 3 as the atomic number, and so if you had to draw, you find that in its outermost shell it will have only 1 electron, so that's why it's in group 1. If you had to draw beryllium, you're going to find that it has 4 down here. So in the first shell we are going to have 2. In the next shell we are going to have 2, which means it's in group 2. If you go to boron, just like that, all those positions according to groups are determined by the number of electrons in the outermost shell. So let's see. Let's pick oxygen just randomly. We are picking oxygen. Oxygen has a mass number of 16 and has this one here happens to be oxygen. So if you can see clearly here, oxygen has 2 electrons in the first shell and 6 electrons in the outermost shell, which means this is in group 6 of the periodic table. Yeah. Now let's talk about how the periodic table can help you determine the valency of each element. Now, when we say valency, what we mean is basically the number of electrons an element, if it's a metal, has to lose for it to be stable, or if it's a non-metal, we're talking about the electrons that it has to gain for it to be stable. Sure. So you can use this tactic. All group 1 elements have a valence of 1. All group 2 elements have a valence of 2. All group 3 elements have a valence of 3. I've skipped these here. Remember I said their valences are not specific. So they have the valences that vary. They don't just have a single valency. So these are in group 4 and their valence is 4. Those in group 5, their valence is 3. So we begin to come or to load down 2, 1, and 0. So these that are here, these that are called noble gases, they have a valence of 0, which means they do not react. That's what it means by noble gases. They are innate gases. They don't react. So it means they have their outermost shell filled up already with 8 electrons or 2 electrons in a duplicate state for helium like this. So, which means there is no need of gaining an electron, there's no need of losing an electron. The valence is 0. So, as you can see again, group 1, 1, group 2, 2, group 3, 3, group 4, 4, group 5, 3, group 6, 2, group. So what I mean is this 2 is for all of them, this 4 is for all of them. So elements in group 1 are called alkali metals. Elements in group 2 are called alkali earth metals. These elements here are called transition metals. Those in group 5 are called nitrogen. Those in group 6 are called chalcogenes. Then our halogens here, the salt formers. And we have noble gases here, gases that don't react. Sure. So basically that's about it. If you have any question, feel free to post it. Feel free to post it so that we can learn together. Yeah. So, but I would love you to always remember that. Let me give an example of just lithium itself. And we have 3 as an atomic number here. On some advanced periodic tables, you might find that the 3 is the one that is up, and the 7 is down here. Let not this confuse you whenever you come across this kind of a periodic table, but just know that the mass number is always the greatest number between the 2 numbers. Why is it the greatest? It's because in it we find neutrons and protons in the nucleus of that atom. So the protons will have the number equal to the electrons, and then you have the nitrogen represented by the number that happens to be the difference, the remaining. So what I'm trying to mean is, if you're asked to calculate or determine the electrons, the number of electrons, number of protons, and the number of neutrons in an atom, what you do, for example, in the case of the same lithium, you should say electrons are this number. So electrons are 3. Protons are equal to electrons, but remember the protons are not just in these 3, but they are in these 3 that is up here. So protons 3, then when you say 7 minus 3, what remain with is 4. So the neutrons are 4. Thank you very much for joining. This was Pearson, the science teacher. Let's learn together.